2, I got a domain which was original deterministic set of actions plus a deterministic set of goals that was sampled from the uncertain distribution of the goals. Either way, I got a deterministic problem. I know how to solve deterministic problems. Okay, so this is a reasonably well understood way of converting uncertainty into deterministic, uncertainty to handling deterministic solving by doing sampling. Okay, and that's basically what FF was doing. Okay, we'll talk a little bit more about that by, probably you will have your own comments on this next class. And then I'll also tell you a little bit more about heuristics. FF itself can be seen as a sort of a heuristic. So in fact, FF replan, one question that you can have is, when you got S and G, why did you run to solve that problem using FF? Why not solve it using relaxed planning graph? Do you understand what I'm saying? So, which is better? And in fact, I'll tell you that these are essentially independent dimensions. In one case, you essentially can, so when you have a stochastic problem, so if you have a deterministic problem, the only thing you can relax, really, what did you relax in the relaxed plan heuristic? What did you relax? Negative interactions. Okay? Now, when you came to stochastic planning, are there negative interactions? Yes, they are. But there is also uncertainty. You can decide to relax or not relax uncertainty. You can decide to relax or not relax the negative interactions. And that will give you 4 different ways of solving this problem. In particular, we can actually see that I would essentially, I could keep the uncertainty but relax negative interactions. As weird as it might sound, I will allow actions to have multiple outcomes, but I'll just avoid dealing with negative interactions between them. And there is an idea called labeled uncertainty graphs, which I might talk a little bit about next class, which is essentially extension of relaxed planning graphs analysis to actions with multiple outcomes. But it too ignores the negative interactions. So again, the idea I would like to get to you next class, hopefully, and by thinking about this now onwards, is it's not just, once you start being lazy, you can decide what's the right level of laziness. Okay, you can relax on 2 dimensions. You can relax both. You can relax one and not relax the other. And so in this guy's case, they relaxed the uncertainty, but did not relax the negative interactions. I could have not relaxed the uncertainty, but relaxed the negative interactions. That would be labeled uncertainty graphs. I could relax both, in which case just one relaxed plan would be what I would use to solve this problem. Okay? So we'll talk about all of those when we come back next.